Hello and welcome to my second Max tutorial. My name's Robin and I'm talking to you from sunny Limerick, Ireland, and it is sunny at the moment, which is a nice change this spring. This is my second Max tutorial and I'd like to fill in some of the details around abstractions that I passed over or didn't have time to get to in the first tutorial. So this will have some beginner material, but it will also have some more advanced topics that I'm going to look at. So if I can actually just start a new file here. I have a new file here. What I'll do is I'll put in the topics. I want to talk about subpatchers versus abstractions, the difference between the two. Arguments and named arguments, two ways of passing data into our abstractions. And finally, an advanced topic that I'll just touch on, how we can use scripting to increase the flexibility of our abstractions. So all of this is under this kind of heading here, Abstractions Revisited. And why do we use abstractions? Well, I hope I drilled that into you last time. It's all about structured programming. It's all about creating code once and reusing it many times so as to save yourself time and frustration. And visual languages like Max do not always encourage this approach. They encourage a more mucking about approach, trying things, experimenting, and that has its place for sure. I'm sure you've dived in and started a patcher and ended up after an hour or an afternoon with an unholy mess, and that's perfectly fine as well. But if you're going to move forward from that, you probably need to do a little bit of tidying and organization, and that's something which a theme that I return to time and time again. So to start with the first of these topics, what is the difference between a subpatcher and an abstraction? And in my first tutorial, I actually misspoke twice in the length of that tutorial and used the word subpatcher when it was inappropriate. A subpatcher is a simple way of hiding code that you don't really want to look at. So I can perhaps just create a most trivial example of that by coming up with some sort of a simple operation like multiply, integer multiplication. So and I'll mention a beginner topic here as we go. As you know, with multiply and other mathematical objects, only the left inlet is hot. So if I change the right inlet, the value going to the right inlet of the multiply, nothing is happening here. The output is not reflecting any change. What you need to do is bang the left inlet, which is the hot inlet. So as I change this, the values update just fine. As I change this, they don't. This is corrected with a trigger object. It's not a mistake, by the way, that Max works in this way. It's to give us a lot more flexibility in how we code. However, quite often, in a simple case like this, we actually want two things to happen when you change this number. And trigger, or T, is the object that you're going to see an awful lot of, and I want you to use it all the time in order to make sure things happen in the right order. So when this number changes, the first thing that happens is the right outlet here sends the integer, I specifies integer, through to the multiply object, and it just holds that number in here. So as I've changed it to 2, this is now implicitly saying times 2. We don't see that 2 anywhere here, but it is stored. That way, if I change this left inlet to 5, it then calculates 10. But go back and change this here. The second thing the trigger does is it sends a bang to the left inlet. So the first thing it does is it stores the integer in the multiply object, and the second thing is it bangs the hot inlet to get a result. Two things in one. Well, say we find this all very complicated and we want to hide it away. We don't want this in our patcher. We can select the stuff that we want to hide and choose encapsulate from the edit menu. Very handy feature that was added somewhere along the way, Max 5 or something. And if we do that, we're given a patcher that we can name, multiply, and the functionality remains the same. We can test that quite simply. Oh, we need to initialize both numbers though first. That's a good illustration of something there. But once they have both initialized through the subpatcher, then it works just fine. And in the multiply subpatcher is the exact same code we had before. The inlets and the outlets have been added for us. That's what the encapsulate does. It saves a bunch of copy and paste and connecting up patch cable nonsense. So this is a subpatcher. Its only real benefit is it hides code from this main patcher to organize it. All of this is still stored in the same file, which, by the way, we should probably save. Untitled, that's not very good. How about I save as subpatcher demo, for lack of anything better to call it. So the subpatcher code is in that same maxpat file. There's only one file for everything. So cool. That has some marginal utility value in order to, it keeps our main patcher clean. However, what often happens is you want to do this in multiple places. You want to use the same operation. And does that work? Yes, that works. I can change this and it multiplies independently of this. Fine. Everything looks fine. But now, the very next thing you're ever going to want to do is change how multiply works. You're going to want to change, say for some reason, and this is completely made up, you want to add 10 to the result. Like that. So I've edited this, save, close it. So now when I change this, 5 times 5 is 25 plus 10 is 35. I've added 10 to the result. It works. And over here, it does not work. Over here, it's not adding 10 because if I double click, this subpatcher has not changed. And why should it? It's independent code within the main patcher. It's highly misleading though, because they have the same name and possibly one might commonsensically expect the changes to ripple through. They don't. These names are pure convenience. You can actually leave them out entirely if you want. That's the difference between a subpatcher and an abstraction. So in this case, if you want to duplicate code, a subpatcher is the incorrect way of doing it. I can just be bold and say it's incorrect. Instead, let's save this out as a file. Actually, we can call it multiply.maxpat. Why not? Put it in the same folder as the rest of our work. Now, that is a separate file, and we can address it as a separate file like this. So this shows up as an object like any other in Max, and it works. Once we initialize both again, 6 times 4, 24, plus 10, 34. So this works. Now, if we duplicate this, initialize them both, it's getting 2 times 2 is 4 plus 10. And if we decide to edit one of these and get rid of that plus 10, we're actually editing a separate file on disk that is used in 2 places. So both will be updated and the results are correct. That's why you use an abstraction. And that's why we were using abstractions last week. So that's the first topic, the difference between the two. Abstractions let you write reusable code that you can change once, and that change is reflected everywhere. They are separate files on disk and can be used for multiple purposes as well. Now I'm going to jump to a different sort of topic, And for that, I'll probably change my patcher around a bit. A lot of built-in Max objects take arguments. Tempo, there's the tempo, and 1 and 8 specify an eighth note gets the beat. There are 3 arguments to that, which are specified. We know from the help file what they're going to be. We can do the same in our own objects very easily. So what I'm going to do is, let's say I want to multiply 3 and 4. And what I'm going to do is I'm going to set this up just slightly differently. When I give it a bang, it will go ahead and do that. Okay, so let's edit this. This is actually quite different now. Whoops. We need to save an integer value. And I'm going to use #1 for the first argument and #2 for the next argument. So these are normal integer objects, but we're giving it a default. And those defaults have this special notation to show it's coming from the arguments. So then when I give it a bang, I actually want to give both a bang. Whoops. So trigger once again. To both of them. That will multiply together. Like that. Although I could have just duplicated this to begin with, we need to also put in our, well, it's not strictly, it might not be strictly necessary, but I prefer to put this in because it just conforms with the pattern I expect to see, the visual pattern, the design pattern that I expect to see for a multiply. So here we are. Okay. Now, when I lock it, you notice these changed immediately to 3 and 4. So if I unlock it, I can see the actual code, but when I lock it, the substitution occurs. So now if I go here and hit bang, the result is 12, 3 times 4. So this is how arguments work. Or this is the simple way in which you can make arguments work, but I'm going to show you a better way in just one moment. Where's my multiply? There it is. So this is all well and good, but #1, #2 is a little bit cryptic. And at some point in Max, they actually instituted a more organized way of handling arguments in a patcher using an object called patcher args. And what you can do with this is provide defaults. Let's say the defaults are actually both 0. And when this patcher loads, this automatically reads any arguments that were provided. If they're not there, it gives them these defaults that we put in, just zeros in this case. Otherwise, it's going to spit out the results here as, it says, a list of arguments. So we can unpack into 2 integers and send those on their merry way, populating these objects here, which then it's redundant to have the pound signs. I'll get rid of them like this. So this is the recommended way of doing arguments because it's much more powerful and flexible. Let's just see if this works. Whoops. Go back here, give it nothing. So no arguments are specified. It will use the defaults. 0. Five and 3 is 15. Okay, so this is how you should use arguments. Don't use the #1, #2. I mean, you can, but it's a little bit cryptic and it doesn't give you the same kind of power that this does. And one way I can illustrate that is to carry on to our third topic immediately, which is named arguments. Sometimes it's cryptic. It's not self-documenting just to have numbers here. And you'll know that quite a lot of Max objects have slowly added these named arguments so that you can name each one. Now in this case, when you're multiplying two numbers together, it's hard to come up with a good name. But I'm just going to be fanciful and do this. So I'm going to call the first one John, and that's 34, and the second one Susan, and that's 26. And I'm going to multiply these together, apparently. Not sure why I'd be multiplying together people's ages, but there you go. So because I'm using named arguments, this works differently. PatcherArgs works differently. First of all, I would provide the defaults. Let's say the defaults will be when they're children. Again, for no good reason. And this time I use the right outlet, which says a list of attribute arguments. But this does not work the same way. So let's see how it works. Let's put a print statement in here. You can name your print statements so that you know what they refer to over in your Max console, which is here, like that. Bring my Max console in so you can see it. I'll just tweak this just so it updates. And Max console. This is what it shows us. So we gave it John 34 and Susan at 26. What it spat out of PatcherArgs out of the right outlet was Susan 26, so it does them right to left apparently. John 34, done. Not what you might expect. This is why it's good to check what objects give you with print statements. Perhaps not what you expect. Not what I would have expected anyway. But now that we know that, we can deal with these arguments. So it is not a simple list. In fact, it's 3 items, the 2 items plus 1 more that tells us when it's finished. So, okay then. How are we going to deal with that? Well, it's not that difficult. We want to first select done. Whoops, 2 L's by mistake. Because we want to ignore done. So if the input matches done, we'll get a bang out of the left outlet here. Ignore that. We'll just use the ones here. And if this gives us some results, we want to route them to the correct place. And we'll do it like this. John will populate the first one and Susan the second one. Here we go. That's it. Make it slightly neater. So Susan 10 will be the first message out of this right outlet. It does not match done, so it will be passed on to here. Susan matches the second item in the route, and so the second outlet sends the remainder of that message. So it doesn't send Susan, it sends what comes after. And likewise for John, and then the third thing we get out of PatcherArgs is just the message done, and we ignore that. I'll mention in passing that this object, you might pronounce it root. There's a tendency among bit heads and coders to pronounce it in this American way, route. And that is because, although I'm not American, I do that because we already have root. Well, we don't have an object called root, do we? But we already have the word root used all the time in coding and computer science. You've got, root access, root folders, all sorts of things. So quite often this word is pronounced route, as in an internet router, to distinguish it. So no comments, please, about my terrible American English. or Canadian English for that matter. Well, you can. Why not? Comment about whatever you like. Be friendly, but comment about whatever you like. Yes. So this should work. Should is never a good word to use in programming. Always test it. So once again, I'm just going to do this just to make sure it initializes. And what happens if I, boom. Yes, 884 is indeed 34 times 26. You can prove it to yourself if you have any doubt whatsoever. And if I was to say omit Susan, if you remember the default's 10, I have 340. So the default value is working. If I was to put in some other thing, the giant is 245 years old. That's just ignored. We're not doing anything with the giant. We're only dealing with John and Susan and their magical beans. Jack, should be Jack. Darn. That is how we use named arguments in our abstractions. Again, it's not that difficult. Once you have this design pattern down, you just copy and use this all the time. What I like about it is self-documenting. You really don't need to provide comments here. And also when you're using the object, when you're using the abstraction, it's self-documenting. Finally, the fourth and last topic I'd like to address in this tutorial is most easily done if we go back to, if I get rid of that, get rid of the Max console. And if I go back to what we looked at in the first tutorial, this is our main patcher, which allows us to turn our DAC on and change the volume of a sine wave. Very simple. And we implemented it using an abstraction in a B patcher. So I'd like to show you a little bit more about that now, and in particular how we can script through this B patcher using an argument. So it ties in what we've just done and extends it into what is actually quite an advanced and powerful technique, which you may not need often, but when you need it, it's really important. So I want to make this abstraction even more versatile. Let's say sometimes I just don't want to look at this waveform. I don't need that in here at all. So I want to turn that object, that visual UI object, off. I don't even want to see it. So sometimes I'll call this abstraction and I want to see it. Other times I don't want to see it. So that is a good case for sending an argument into here. And how do you do that with a B patcher? Because there's nowhere you can explicitly write it like this 220 Hertz for our cycle tilde. Well, naturally it's in the inspector, isn't it? If you scroll down to the bottom, you've got your patcher file indicated. And right below that, you can enter arguments. So say I want to hide. I'm going to send that the argument hide to hide this oscilloscope type display. So let's go to our audio output patcher. We need to make this react to an argument. We know how to do that now, patcher args. And there's just the one argument we're sending it, which is either hide or I guess show. So by default, let's put in show. But sometimes if we toggle it to hide, we want to select that option and do something with it. And what we're going to do is we are going to literally hide this object. So first we need to be able to address this by name. We need to give this plot tilde a name. Scripting name happens to be right at the bottom. So let's call it our plot, for lack of anything better. And how do you hide it? You have a message that says script. The actual message is in fact hide, and you want to address it to the correct object by its scripting name. And this gets interpreted by an object called this patcher. This is a message to this patcher, which can understand all sorts of messages. You can create new objects and destroy them and move them about the screen and color them and everything using this. So again, just to run through this, patcher args is going to get the first argument, If there isn't one, the default will be show. Otherwise, we will use the word hide. Anything else will be ignored. So we select for the case where we have specified hide. Select will send a bang to this message, script, hide, our plot, where our plot is the name of this scripting name. There. That's actually the scripting name of this object. And that message is sent to this patcher, which will hide this object. It will. So let's save this and switch back to our main. Boom. It's already happened. It's already happened because we already put that argument in down here. We already put the argument hide in. So it is in fact hidden. So in this case, we probably want to change this display, probably, or at least do something maybe like that. I don't know. It could be done a bit nicer, in fact, but I'm just doing a quick and dirty demo here. So if we get rid of that argument, or in fact change it to any other text in the world, this shows up again because the default was show. Just to quickly review, we looked at the difference between subpatchers and abstractions, how we can get arguments into our abstractions, in fact, two ways, sort of the deprecated way with the # and the preferred way with patcher args. We looked at named arguments, which are also supported through the object patcher args, and a very brief introduction to scripting and how you can tie that in with your abstraction, with your bpatcher even, which is sometimes a very, very handy thing to be able to do. So thanks for your attention. I hope you enjoyed this. If you did, leave comments. If you're unaware, I do run lots of tutorials and provide code over on my Patreon site. Much of that is open. Some of it is reserved for my supporters, and I really appreciate all the support I get. If you buy me a coffee every 3 months, that's basically what it costs to support me, and it just means that I have more time to put these videos together, and it means I have more time to address your own concerns. So let me know what you'd like tutorials on, the subjects that you need help with, and I will try to help you out, because that's what it's all about. The other great thing about Patreon, well, the best thing about it is the community aspect, I think. The fact that it puts me in direct touch with people who are reading my stuff on the web. I mean, I have probably, I have 700 articles on my blog and a lot more in other places. So I've probably got it, I probably get messages and emails from stuff I did even 10 and 20 years ago, and it can be a little bit hard to know what to focus on today. So Patreon makes it very immediate and very now. It's very 2018. So again, thanks everyone for your support, and I'll see you again soon.